Hello dear students, my name is Vikram Nalode. I am from the Department of Mechanical Engineering. I work at Sharad Institute of Technology, College of Engineering, Yadra, Ijalganji. In today's lecture, we will cover the transmission system, in which we will focus on differential and its types. So let's start today's lecture with the content. This GIF shows the function of differential gearbox. So here the content of today's lecture is function of the differential. Then we will discuss types of differential, then parts of differential, and we will focus on the working and the mechanism of differential gearbox. So let's start with the function. So first of all, I will tell various names of the differential gearbox parts. See, this is the propeller shaft, which is in rotation and takes power from the driving unit, that is the engine. Then this is the rear axle, over which entire differential mechanism is mounted. It runs here. This is the inner half shaft, this is the outer half shaft. Here this is the crown wheel, and here this is the pinion. This is the large gear, this is the smaller gear, this one is also smaller gear, this is the larger gear, and this is the rotating case. So the function of the differential, it transfers power from drive shaft to the wheels. So this is the propeller shaft which transmits the power. It receives it from an engine and delivers it to the wheels via differential. Then it provides final gear reduction. Next function, it splits amount of torque going to each wheel. Then it allows the wheels to rotate at different speeds in turns. Now there are types of differentials. First is open differential, lock differential, active or electronic differential, limited slip differential. So let's discuss about power flow of the differential, as we have already discussed the names of the parts associated with differential. So in power flow, drive shaft spins the pinion gear. Then pinion gear turns the larger ring gear to produce reduction. Ring gear attached to the differential case, hence it rotates with the ring gear. Differential case spins the sun gears, which are attached to the axles, and axles transfer the power to the wheels. So in this manner, power is flowing from the driving unit to the rear axle through propeller shaft and differential gearbox. So here differential gearbox plays very important role. So this block diagram represents the action taken by the differential gearbox. Generally the inner and outer wheels of a moving vehicle do not always rotate at the same speed because of road conditions, and especially when the vehicle has to take a turn. So this is the This is the unit. This is the unit which is connected with the engine part. It receives power, and with the help of transmission system and propeller shaft, it directly delivers it to differential part. So here this is the gear number 1, gear number 2. So power transfers to the gear number 2 from the gear number 1 of the rear axle. So this is the rear axle. Here wheels are connected. Here wheels are connected. Now in turn, this is the representation of the differential. The gears are numbered as 3, 4, 5 and 6. So when the differential units, means the gears 3, 4, 5 and 6, is in action, the two sides can have different rotational speeds due to the mutual rotation of gear 3 and 4. This will help in case of turning. Now let's discuss various parts of differential: pinion drive gear, ring gear, differential case assembly, rear drive axles, rear axle bearings and axle housings. If you talk about pinion drive gear, so it transfers power from drive shaft to the ring shaft, means it takes it from the engine part, from propeller shaft, and directly delivers it to the rear axle. Then next is the ring gear. This is the bigger gear, is the ring gear. So it transfers power to the differential case assembly. Then differential case assembly. So it holds the ring gear and other components that drive the rear axle. The next part is rear drive axles. So this is the rear drive axle. These are made up of steels, so steel shafts that transfer torque from the differential assembly to the driving wheels. Then rear axle bearings. So in such type of part, ball or roller bearings that fit between axles and inside of the axle housing. And next part is axle housing. So this is the metallic body that encloses and supports parts of the rear axle assembly. So generally these are the main parts of the differential gearbox. It consists of two planet pinions, two sun planets, cage, crown wheel and bevel pinion. The crown wheel of final drive is bolted to the cage. The sun pinions mesh with the planet pinion and are attached to the axle shafts carrying the wheels. The cage is provided with a cross pin or spider depending upon whether there are 2 or 4 more planet pinions. The crown wheels are free to rotate on the half axle shaft, and the drive to the crown wheel is transmitted through the bevel pinion, which meshes with it. This bevel pinion is connected to propeller shaft through the universal yoke. So these are the functioning of the various parts of differential system. Now let us discuss about the working of differential. So the inner and outer wheels of moving vehicle do not always rotate at the same speeds because of the road conditions, and especially when the vehicle has to take a turn. At that time, the inner and outer wheels move along the curved path. So this is also shown. This is the inner wheel turns more slowly than the outer wheel. Here it shows traveling straight ahead road. Both wheels turn at the same speed. So in both conditions, the speed varies. So when front wheels are rotating, its center is lying somewhere here in the same axis to the rear axle. So when turning, the inner and outer wheels have arcs of different turning radii. Consequently, the inner wheels travel less distance than the outer wheels. So for its operational point of view, we have to consider some points. So let's consider first point: when the vehicle proceeds straight ahead, the following some of the aspects relate to the operation of the differential setup. So first condition, when the traveling is in straight ahead condition. So the crown wheel turns the cage. The turning cage makes the pinion gears and axle side gears to move around. However, the pinion gears do not rotate on the crosspin, and apparently there is no relative movement between the teeth of the pinion gears and side gears. The side gears are acted upon by equal torques and drives both the half shafts at the same speed, and the vehicle moves on. During this straight travel, the various differential gears, crown wheel, differential cage, crosspin, pinion gears, and side gears turn as the solid unit. That is, there is no relative motion amongst them. So this is the condition when the vehicle travels in straight path. Second condition we will consider: when the vehicle takes a turn, consider towards the left. The left inner drive wheel then goes through a sharper corner. That is, it has to travel through a shorter distance than the right outer wheel. The left wheel encounters greater resistance, and the left axle tends to momentarily slow down. The planet pinions are still turning and rotating on the cage shaft. Apparently, they walk around the slowed left axle and provide greater portion of the power to the right side gear. The right wheel will then turn faster than the left wheel. The speed lost by the left wheel is added to that of the right wheel. And third condition we will consider: suppose one wheel is on a muddy surface. So what aspects we have to consider? In that condition, the wheel fails to grip due to extremely low friction resistance of the muddy surface. The wheel merely spins at greater revolutions but does not move. Some of the aspects we need to keep in our mind: that there is no direct connection between crown wheel and axle shafts, and the planet pinions rotate on their axis when unequal resistance is encountered by the road wheels. And third condition that we have to keep in our mind: the larger resistance leads to less rotation, whereas smaller resistance will have more rotations. So all these are about the working phenomena of the differential. Now we will consider it is clear in this picture that for a left turn that we have discussed right now, for a left turn the right wheels travel more distance than the left ones. So you just observe the passage followed by the vehicle and how vehicle turns in the left condition, so it covers more distance than the left ones. So here these are the front axle that is free, so both wheels turn separately, and here engine needs to turn the right wheels more than the left wheels in the same amount of time. So these two arcs are represented, smaller arcs and the longer arcs. This is where differential comes into action. Now let's discuss some of the points of troubleshooting. We'll focus on the troubles, its causes and remedies and differential. So first trouble we consider here, that is the gear noise. First is the gear noise. Generally insufficient lubricating oil replenish with the correct amount. Then in the gear noise, low viscosity, poor quality oil. So what remedies we have to take? We have to replace with correct quality of gear oil. Then next trouble encountered in during the gear noise is wrong adjustment of dry pinion and ring gear. So remedies, we have to adjust it properly. Then trouble for gear noise is improper tooth contact in mesh between the dry pinion and ring gear. For that remedy, we have to adjust it or replace. The next causes of gear noise: broken or damaged teeth of side gears or differential pinion gears. So remedies, we have to replace it. Then next trouble is second one, that is bearing noise. So the causes are damaged or worn bearings or worn parts, constant noise. So remedies are to replace it. Then insufficient or poor quality gear oil, then we have to replenish or replace as the case may be. Then in bearing noise causes broken bearings on axle shafts. Remedies, we have to replace it. And if there are damaged bearing of rear dry pinion, then again remedial action, we have to replace that part. Then last trouble which we face, that vehicle does not move when put in gear. So what are the causes? Generally broken teeth of crown, wheel and pinion, then broken cross or star pinion, then broken flange key, broken propeller shaft or broken axle shaft. So these are some of the causes due to which vehicle does not move when put in gear. So for proper remedial action, the broken part needs to be replaced. So in such manner we have to do its troubleshooting. So in that manner, that differential can be made easy to operate. So in today's lecture we have discussed about differential gearboxes. Hope you have understood the concept. In next lecture we will